Density and specific gravity. What are they? First, let's talk about density. Density is not one of the base units. Density is what we call uh, a combined unit, where we take different units, combine them together. It's basically the ratio of mass over volume, mass divided by volume. Density equals mass divided by volume, and mass could be in grams. More generally speaking, it's in grams, while volume could be in milliliters, centimeter cube, or centimeter cube written another way, cc. You may have seen this format as well. Why do we want to know about density of an object? Density is something that characterizes each substance in a way that helps us to identify that substance in case we do not know what that substance is. So let's have a look here. We have four different substances here. There is water in this container. Then on the bottom, there is not water, there is liquid mercury. Mercury is a metal, as we will learn later, which happens to be liquid at room temperature. Remember, room temperature is 25 degrees Celsius. Here we have a brass nut. Brass is an alloy made from metals. And here we have a cork made up of wood. You notice how all these items are at different places within this liquid water. Now, liquid mercury is under the liquid water. It's not floating above water. Why? Why isn't it floating above water? Because the density of liquid mercury is greater than that of liquid water. The brass nut is also more dense. It's a solid that's denser than water. It has a higher density than water, hence it's also submerged, it drowns. On the other hand, cork has lower density than water. Remember, this is not just the mass. Mass wise, even if you took just one drop of liquid mercury and dropped it in here, the one drop as a whole should weigh less than the glass full of water, beaker full of water, but even then it's going to sink. On the other hand, if you had taken a large very heavy log and tried to float it in here, assuming you can in this small beaker, it would still float. Why? Because it has lower density. Let's look at densities of different objects, different substances rather, and some objects as well. So here lead, for example, has very high density. The density of lead is 11.3 grams per milliliter. Kerosene is a liquid, flammable liquid that was used in the past, and nowadays it's used less but still used. It's 0.82 grams per milliliter. So it's less dense than water. If you had kerosene and water mixed, you would expect kerosene to float on water, just like oil generally floats on water. What's the density of water? Well, here you have it. The density of water at 4 degrees Celsius is given with 3 sig figs after the decimal point, total 4 sig figs, as 1.000 grams per milliliter. Density of water at 20 degrees Celsius is 0.998 grams per milliliter. Wood, because we have different kinds of trees and different kinds of woods, the densities range anywhere from 0.3 grams per milliliter to 0.98 gram per milliliter. And go over this list. You don't have to memorize this, but just be curious about few things. Milk and water mix. That's why, despite the fact that milk has higher density than water, you will not see any separation between the two. Now, mercury we saw previously as being more dense than water, and mercury and water do not mix, so mercury will sink to the bottom. Methanol is a kind of an alcohol which mixes with water, but it has a lower density otherwise. You will notice that gases have very low densities given in grams per milliliter. So density of hydrogen gas is 0.000090 grams per milliliter. Density of carbon dioxide gas is 0.001963 grams per milliliter. Gases mix with each other, so there is no point in saying that one gas is not going to uh, sink while the other will sink. Generally, gases are going to mix into each other, unless you put them in a balloon like the helium balloon, and then since it cannot mix with the surrounding air, it's going to start to rise because it's going to have less density than the surrounding air. Now, what do we do with density? How can we use density to solve problems? So let's look at a problem here. A 2.00 centimeter cube sample of aluminum, that's the volume, is found to weigh 5.40 gram, that's the mass. Calculate the density in grams per centimeter cube and then grams per milliliter. Well, since density equals mass over volume, all you do is take the ratio of the mass over volume, solve for this to the right sig fix, and you have your density in grams per centimeter cube. The relationship between centimeter cube and milliliter is 1 centimeter cube per milli equals 1 milliliter. So when we say 2.70 grams per centimeter cube, that's the same as saying 2.70 grams per milliliter. So that's the density of aluminum metal. Now here in this problem, we are told something else. We are told the density and the mass, and we are being asked for the volume of a liquid. What do we do? How do we solve this problem? Well, we can write density as a conversion factor as well. 1.20 grams per milliliter, and that's our conversion factor, and we can flip it and make it 1 milliliter over 1.20 grams. We will use one of these two conversion factors, multiplying it with the data given. The data given in the problem, apart from the density, is 5.00 grams. Multiply 5.00 grams with one of these two, that cancels out the grams, and it's the second one that cancels out, and we get 4.17 milliliters. So now we are not solving for density, we are rather solving for volume given density and mass. And here are some more problems that you should try solving. Pause your video and look at these problems and try to solve these problems. Now, what is specific gravity? Specific gravity is the ratio of the density of an object in question, whatever that object is, to the density of pure water at 4 degrees Celsius. So the density of water is different at different temperatures, and generally speaking other objects also display that property, changing a little or more with temperature. And we have chosen 4 degrees Celsius temperature of water as the density to compare for the calculation of specific gravity. So whatever is the specific gravity of your object divided by the density of water at 4 degrees Celsius. And this is what we use to test in the health industry, test urine and blood samples. So it might be something that you will come across a lot going forward.